In this video, we are going to see electric field due to a dipole on its equatorial plane. When you see the figure, you may think that it is very difficult to draw, but I can teach you in simple methods how to draw this figure. See, we know that any charge, positive or negative, creates electric field lines, and this positive charge produces electric field lines. They are protruding outwards, and the negative charge produces a field which comes towards the charge, right? We know that. Consider a dipole minus q and plus q at points A and B, and C is the midpoint of dipole, and 2a is the distance between the dipole. Let us consider a point C, and it is at a distance r from O. We know that the charges plus q and minus q produces a field at this point. So we shall see what is the field produced, right? See, the positive charge will produce a field which is moving outwards. And so the field at this point will be outwards along the line joining B and C. And so the direction will be BC. Now let us see what is the electric field produced at C due to minus Q. The negative charge will produce a field which is coming towards it in the direction of CA. The resultant will be by taking the parallelogram law. P is the dipole moment. P is in the direction of minus Q to plus Q. And you need not panic for drawing this picture. First, you draw the dipole, plot the point C and draw this CO, then join this triangle. Then, along this line BC, you extend it, and here along CA, you extend E minus, and you complete the parallelogram, right? Why do we need this parallelogram? You have a doubt, isn't it? We need this parallelogram to find the resultant of two vectors. We will construct a parallelogram, and the diagonal of the parallelogram will be the resultant. The picture explanation is like this. AB is electric dipole, 2A is distance between charges, R is distance between O and C, and vector E is electric field, and vector P is dipole moment. This picture explanation is enough. So let us see how this E total we are getting. First of all, let us consider E plus. And E plus is along this direction BC, and it must be resolved into two components. How we could resolve is, see, theta is here. What will be the adjacent side? It will be E plus cos theta. The other resolved component will be E plus sin theta, right? For E minus, what will be the resolved components? By taking the angle theta, the adjacent vector will be E minus cos theta, and the other vector will be E minus sin theta. So E plus sin theta and E minus sin theta, they are of same magnitude and they are opposite. So they get cancelled. Total of the E plus component, E plus cos theta, and E minus component, E minus cos theta, they are getting added up. And so we get the E total. And so the E total will be E plus cos theta unit vector of P and E minus cos theta unit vector of P. Why do we get this minus? Minus comes from the P vector. See here, the dipole moment is opposite in direction to the field, and so we get a minus. Okay, first we have to draw the picture, then write the picture explanation, and we write E total is equal to minus of the magnitude of E plus cos theta unit vector of P minus the magnitude of E minus cos theta P. And what is the value for E? The value for E is 1 by 4 pi epsilon 0 Q by R square. We know it, right? And unit vector of P. E at C due to plus Q. It will be E plus. And the magnitude of E plus will be 1 by 4 pi epsilon 0 Q by R square plus A square. Why do we write R square plus A square? See here. In this triangle OBC, this is a right angle triangle, right? And OC is R and OB is A. So what will be this side? BC. It will be root of R square plus A square, applying Pythagoras theorem. And so here we have Q by R square, isn't it? So R square. So squaring this, we get, the root gets cancelled, and so we get R square plus A square alone. What will be the field due to minus Q? The field due to minus Q at C will be 1 by 4 pi epsilon 0 Q by R square, and R square is root of R square plus A square, because these are similar triangles. So CB is equal to AC, and so it is root of R square plus A square. Squaring this, the root gets cancelled. So here we get R square plus A square. We can see that E plus is equal to E minus. The value is 1 by 4 pi epsilon 0 Q by R square plus A square. And what will be E total? We shall add it up, right? The minus sign we get out here. Both have 1 by 4 pi epsilon 0, and Q and Q added up, we get 2Q and cos theta divided by R square plus A square into P vector. What is cos theta? See here in this triangle OBC, theta is here, and what will be the value for cos theta? Adjacent side by hypotenuse. So adjacent side is A and hypotenuse is root of R square plus A square. And so cos theta is adjacent side A divided by root of R square plus A square. And so we'll get E total is equal to 1 by 4 pi epsilon 0 2Q divided by R square plus A square into the value for cos theta, A divided by R square plus A square the whole power half. Root we can write it as R square plus A square the whole power half into unit vector of P. So here R square plus A square the whole power 1 and R square plus A square the whole power half. So 1 plus half 1 and half, that is 3 by 2. If we consider 2AQ into unit vector of P to be the dipole moment, we know what is dipole moment, right? Magnitude of one of the charges into distance between the dipole, that is 2AQ into unit vector of P is equal to vector P. And so 2AQ and unit vector of P could be written as P vector. So E total becomes minus of 1 by 4 pi epsilon 0 P vector divided by R square plus A square the whole power 3 by 2. If R is very much greater compared to A, what will be A square the whole power 3 by 2? It will be A cube. 2 and 2 will get cancelled. A cube. If A is very small, what will be the value for A cube? It will be very small, and so we can just neglect it. What will happen to this R square? R square the whole power 3 by 2. So this 2 and this 2 gets cancelled, and so we get R cube. So E total will be equal to minus of 1 by 4 pi epsilon 0 P vector divided by R cube. This is the E total for the dipole at the equatorial plane. This minus denotes that So direction of dipole moment is opposite to that of electric field. You need not write this red color equations for the exam because it is for your understanding. Hope you have understood very well. In this video, we have seen what is the electric field due to a dipole on its equatorial line. Thanks for watching.